Hi, lesson 3 is on combinations. So after this lesson, you've actually learned all of your strategies for counting. You've done all of the lessons on counting, higher level counting. So after this is just practice, practice, practice. And that practice is just getting to figure out all the different strategies and how do you know which one to use it. So that's what's in store for you after this lesson. The last thing that we're going to learn is something called a combination. And a combination is much like a permutation. So first thing I want to talk about is what's the difference between a combination and a permutation. And I'll give you a good example to kind of hopefully wrap your head around. Okay. So a permutation, order matters, is what you'll hear us say. Order matters. And in a combination, order doesn't matter. Okay, so what do I mean by order doesn't matter? And so think about it this way. Let's say that you have 10 people and you're going to choose 3 at a time. And let's say whenever you choose them 3 at a time, you're going to put a position to them. So let's say we have a president, a vice president, and a secretary. Okay, so I'm going to put some people from our class into these positions. So I'm going to make Michelle the president, and let's say make Angel the VP, and let's say Kale is the secretary. Okay, so that's a very specific order. Now, if I switch things up, and let's say I make Angel the president, and then I put Michelle as vice president, and I keep Kale as secretary. They're the same 3 people, and I know I still have 7 others that I can choose, and I can start to count those 7 3 at a time, right? We can get all sorts of different orders, but let's just think about these 3 people. By switching Michelle and Angel, I've created them in a different position. And it's very different if Michelle is president versus if Michelle is vice president. So I have to count both of those arrangements. Order matters. So that's what I mean by order matters. So let's take the flip of that, or the opposite to that. If I'm choosing 3 people at a time, and there's no position to them, it's just 3 people, and if I choose Michelle and Angel and Kale, well, since there's no position to them, that's the same order as if I were to switch Angel, put Michelle here, and put Kale there. I can't double count those because they're just people on a committee. There's no pecking order to them. This is a combination, whereas this is a permutation. Okay, so the example we're going to do is on page 104, and it has to do with cards. And whenever you are dealing with cards, or you're counting cards, then you're actually in a combination, and let's think about why. So it says all the diamonds from a standard deck of playing cards are shuffled, and 4 of these 13 cards are dealt out in a row. How many different permutations of 4 diamonds can be dealt? Okay, so if we're thinking about a permutation, then we're thinking the order matters. So if I'm putting those 4 cards down, and I put, I have the 4 cards here, let's say an 8, a king, a jack, and a 2. Well, what I'm saying by saying it's a permutation is that if I take those same 4 cards and I switch them up, I have to count those as 2 different arrangements. Okay, that's a permutation. Normally in cards, we don't do that. Normally in cards, we would think of this as the same hand. But if they want a permutation, they're trying to get you to see the difference, then this would be, I have 13 P4. All right, you can put that in your calculator, or, I'm still on the screen, I am. The other thing is you could just put down those 4 slots, and you go 13 times 12 times 11 times 10. All right, either one of those. But if you're in a combination, now if I'm thinking that these 2 are the same order, I can't count them twice, then you would do a C. This C button is exactly where your permutation button is. It's in that same menu. So if you go to math and then go to the PRB or the prob, and you'll get that drop-down menu, you should see the C. It should be right underneath the P and along with the exclamation point. So on the screen, you'll put the 13, and then you'll go get that button and then put the 4. So it'll know that the 13 goes with the N and the 4 is the subset. Okay. And those answers for you. So the permutation, you have 17,160 hands. That's a lot of ways to count, a lot of cards to count. But if we think of these as the same order, so now order doesn't matter, then this number drops to 715 hands. So what you can think of, and the next set of problems that you're going to practice, it's going to try to get you to process this idea of the difference between a permutation and a combination. And what you want to think about is your combination is always going to be a smaller number because you're dividing out repetition. You see it in the formula, and we'll look at the formula in the next examples. But that's kind of basically what you're doing, is you're thinking, well, if these are the same order, I can't count them twice. You're dividing out repetition, so you should be counting less. Your numbers should be less. So the next, you're going to practice some. You're going to pause the video, and there are practice problems are on page 104 to 105, numbers 1 through 5. When it asks you to determine the number of permutations and combinations, if it says to actually like draw them out, I think it's number 3. I'll go here, number 3. It says write out all the permutations of 3 letters. Don't do it. That's way too much time, too time consuming. We really want to cut to the chase, and we want to figure out how many there are. So for number 3, let's see if I can go back. For number 3, just determine the number of, don't list them out. Okay, so you can pause the video and you can try numbers 1 through 4, check your answers. When you think you have it, you can come back. I'll take a minute and I'll explain some of them, put the answers up. If you don't think you need that, zoom right through it. And we'll go on to the next example for combinations. Okay, so some of the explanations for this, the connections that you want to make is, for number 1, it says how many different permutations are there? 3 objects chosen from a set of 5. So it does say permutation, so we're doing 5p3, which is 60. And then how many different ways are they arranging each subset of 3 objects? So that's just 3 factorial. Versus how many different combinations of 3 objects would be 5c3, which is 10. So it's a good one to show some of the differences in the type of counting that you're going to do. A permutation, we're choosing a subset. Just 3 objects at a time, you're arranging all of them, becomes the exclamation point. A combination where order doesn't matter, we're choosing a subset. Number 2, how many permutations can be formed using all 5 symbols? So since we're arranging all 5 symbols, factorial. How many combinations can be formed using all 5 symbols? Combinations now means that if I use this, but now let's say I switch the star and the fidget spinner, and I don't even know what some of these other ones are, that's the same. So for part B, they would be the same order. So how many ways can you arrange 5 things? You could think of it as a combination, 5, choose 5, which is only one way. And then there's your explanation for part C. Number 3, write out all the permutations of 3 letters. We're not going to write them out. How many are there? So I have 4 that I'm choosing from. 4, choose 3. Oh, but it said permutation. So I'm going to put a P there. And then same thing with B, we're not going to write them out, but now we want a combination. Okay. And if we put the numbers to these, this is 24, and this is 4. When it says how many more times, well, I know that there are 6 times as many perms as coms. 6 times as many permutations as combinations. And then number 4, at a restaurant, 12 friends are ordering dessert. Everyone wants the strawberry pavlova, but there are only 4 left. In how many ways can the 4 strawberry pavlovas be distributed if no one is willing to share? Well, if you're handing out the 4 strawberry pavlovas to your friends, the order doesn't matter. So if you think of them like plate 1, plate 2, plate 3, plate 4, if I get plate 1 versus plate 2, doesn't matter, I just get a strawberry pavlova. So that makes it a combination. So that's what you want to think about first, is justify in your mind, why is it a combination? So this is a subset as well. So subset makes it a permutation or a combination. Since the order doesn't matter, it makes it a combination. So that would be 12, choose 4. So there would be 495 ways of handing out those 4 strawberry pavlovas to you and your friends. And then the last one, number 5, is similar to the one before. Write an expression for the number of permutations of 4 objects chosen from 7. So you're choosing a subset. It does want a permutation. So that's 210. Write an expression for the number of ways to arrange each subset of objects. So we're going to arrange all of the objects, 4 of them. And then use your answers to part A and B to write an expression for the number of combinations of 4 objects chosen 7 at a time. And so that's 7 choose 4, which is 35. Okay, I'm going to end this video now so it doesn't become too long, and then we'll do one more lesson with combinations.